Okay, so friends, last time we understood why an IPv6 address is called a 128-bit address. Now in this particular session, let us try and understand the decimal to binary conversion. Okay, so that would help you understand IPv4 address in a better way. So friends, I have been saying that there are 4 fields in each IP address: something dot something dot something dot something. There are 4 fields, so this is the first field, second field, third field, and the fourth field, right? And each field of the IP address is of 8 bits. So friends, now consider I have written an IP address 192.168.10.10. So this is a decimal number. Okay, this is used, reason for using decimal format while assigning an IP address is because it is known. Okay, so anybody can easily identify that it is 192, right? But in the back end, computer understands this in the binary format. So as we all know that computer uses binary language, okay, and that's where conversion of decimal to binary needs to be understood. So friends, as I said, each field of this IP address comprises of 8 bits. So let us try to create a picture out of it so that you understand that little better. It becomes easier for you. So consider I have written an address 1.1.1.1. Let's take a very simple address. Okay, so this is the decimal representation of the IP address. So if you expand this particular field, so it's going to be 1, 2, 3, 4, 5, 6, 7 and 8. So each field of an IP address is of 8 bits. So now if you want to learn the conversion, just remember one number. So it is 1, 2, then 4, then 8, 16, 32, 64 and 128. You can easily remember this. So 1, 2, 4, 8, you just need to keep doubling up the number, right? So how this value 1, so how many bits are there? 1, 2, 3, 4, 5, 6, 7 and 8. So this is the first bit, second, third, fourth, fifth, sixth, seventh and 8th. So that is why I have created these numbers here. So if you want to understand the analogy behind these numbers, so see, it is always 2 to the power the number. So consider 2 to the power 0. So anything raised to 0 comes out to be 1. So that is why 2 raised to 0 comes out to be 1. Now if I increase the exponent value, so it is 2 raised to 1, so it's coming out to be 2. Now 2 to the power, again if I say 2, so 2 to the 4. Now here it is coming out to be 2 to the power 3. So 2 into 2 into 2 comes out to be 8. So likewise, if you keep incrementing the power, finally you arrive to a value of 2 raised to 7, which represents 128. So friends, now consider, I want to, so why I have written this here is to help you understand, or convert a decimal number into binary. So consider this is the, so consider I want to now translate a number, consider 0 into binary format. So binary format, so 0 to the base 10. So I'm talking, this is a decimal number. Okay. Now to translate that into or convert that into a binary number, just now you want 0. So you need to make all these values 0. So I'll just put 0 below all these fields. So I have written 0 here. So this is the binary conversion of decimal 0. So now the bracket is going to be base 2. So binary number, right? Now if you want to create a binary number of decimal 1, so now you want 1. So I'm just using 1 here so that the value is achieved, and rest all the bits I'm going to make it as 0. So now this has become the binary conversion of number 1. If you want to convert decimal 2 into binary, so you need to just on this particular field, so I'm going to put 1 in place of 2. I don't want 1, so I'll make this bit as 0 and again the other bits as 0. So this is the binary conversion of decimal 2. Let us say you want 3. So how can you achieve 3? By you need to add 2 and 1. So what you will do, you will mark 1 here, again for value of 1, again you will mark 1 here. So 1 means you are adding 2 plus 1, so you have achieved a decimal number of 3. So now all the other fields are going to be 0. If you want to achieve 4, then 4 is already there, so you just put on that particular bit and rest bits can be set to 0. So now this is the binary conversion of 4. So this is the binary number of 4, right? So likewise, if you make all the bits, all the 8 bits as 0, then it is going to be 0. If you now at the max, what you can do using binary conversion is that you can make all these values as 1. Nothing else you can do more than this, right? So at the max, you can mark all bits as 1. So 1, 2, 3, 4, 5, 6, 7, 8. So if you mark all of them as 1, then you need to add all these numbers, right? So if I add all these numbers, 128, 64, 32, 16, 8, 4, 2, 1. So 8 plus 4 is 12, 14, then 14 plus 6, 20, 28, 32, 34 and 35. Carry 3, 3 plus 2, 5, plus 6, 11, 12, 13, 14 and 15. Carry 1. And now if you make all these bits as 1 bit to the base 2, will give you a decimal number of 255 to the base 10. It means if you convert all these bits into ones, it is going to give you a number of 255. So friends, this value is going to be 255. So I hope you understood why there is the range for every field of an IP address ranges between 0 and 255. So friends, now I hope you understood this particular concept. So let's move on to the IP address fields again. So if you look at now this particular address, either all fields can be 0 or you can make, so now if you want to achieve 1, what you will do, you will just enable the last bit, that will give you the value of decimal 1. So this is how computer is going to consider decimal 1 as binary 1 in its own binary language format. So now what max we can achieve here is to convert all these zeros into ones, right? So if I convert all these into zeros, it's going to give me a decimal value of 0, and if I make all these binary bits as 1, it is going to give me a number of 255. So friends, I hope you understood that an IP address is of 4 fields, and the lowest value in the IP address can be 0.0.0.0, and the maximum value that we can achieve is 255.255.255.255. So IP address. So this is the first address in the range of IPv4, and this is the last address. Okay, so if you give a netstat command, you will see the first entry as this and the last entry as this. So this is also known as world's NID, world's network ID. So you go anywhere in any part of the globe and look at the IPv4 address, assigned to any of the server or cloud host or a desktop computer in any of the network. So this is going to be the NID for that network. So this is the first address in the IPv4. So world's network ID, right? And this is going to be the world's broadcast ID. Okay, so every network configured today is a part of this main network. Okay, so the first address in IPv4 series starts with 0.0.0.0 and ends with 255.255.255.255. So this is the broadcast ID. Okay, so I hope you understood some more details about the different fields of an IP address. What is how many bits are there, and if you make all these bits, what is going to be the IP address in the decimal format. So this is the first address for the entire network in the world. This is the last address, that is the broadcast address for the world's network. So that was all about the start and end IP of an IPv4 address. So let's try to understand how different classes are created from this IP address. Okay, so I hope you understood the concept of IP address. Okay, let us try to now see how different classes of IP address and their ranges are defined. So thank you for watching. See you in the next session.